principle of moments says that in any system of forces, the clockwise moments will equal the anti-clockwise moments, so that things balance out. I wonder if you can use that principle to find a link between the masses of the cats, the buckets of chicken, and the dynamite, and eventually work out how many cats are inside the white box. Pause the video, have a go at it, and when you want an explanation of it, then restart the video. Or if you just want the answer, go to the very end of the video. So if we look at this bottom right hand section here, you notice this string falls down, and this is where our pivot is of this bottom right section. And these distances here are the same distance. And on the right hand distance I have one cat hanging there. And actually from the left hand side of this mobile here we have another string and 2 buckets of chicken. So actually hanging from here we have the weight of 2 buckets of chicken. And because these distances are the same, the moments due to the clockwise moments due to the cat will be the same as the anti-clockwise moments due to the 2 buckets of chicken. And so I can say that one cat must be the same weight as 2 buckets of chicken. But we can see this elsewhere as well in the diagram. In this part of the diagram, you see the cat and a bucket of chicken around this pivot here. But the cat is 2 units away, and it will provide a clockwise moment. The bucket of chicken is 4 units away and will provide an anti-clockwise moment. And because they're balanced, we can say that 2c equals 4b. Because the distance from the pivot of the cat is 2, so 2 times the cat's weight is equal to 4 units times the bucket's weight. And that simplifies down to c equals 2b. The cat is 2 times the bucket's weight, which is what we found down this right hand corner as well. Now this little pivot at the bottom is separate from the rest of the diagram, but it helps us get a link between the cat's weight and the weight of a bucket and some dynamite. And again, the cat is on the right hand side of the pivot, and its weight will force the pivot to go round in a clockwise. So this cat will provide a clockwise moment. Whereas the bucket and the dynamite, the weight will go in downwards and force an anti-clockwise moment around the pivot. But because they're in balance, we can say that the distance of the cat from pivot, 2 units, times the cat's weight, will be the clockwise moment, and 1 unit times the weight of the bucket and dynamite will be the anti-clockwise moment. And so we get this equation. So 1 times the bucket and dynamite's weight is equal to 2 times the cat's weight. 2 times the cat's weight. But that multiplies out. B plus D is equal to 2C. But in the last slide we saw that the cat was the same weight as 2 buckets of chicken. So instead of 2C we can write 4 buckets of chicken, 4B. And so B plus D is 4B. I know then the dynamite must be worth 3 buckets of chicken. So the dynamite is the same weight as 3 buckets of chicken. But we could also have got that result from this part of the diagram here. If we take moments about the pivot, which the string acts as the pivot here, these 2 weights, the dynamite and the cat, will be a clockwise moment around this pivot, and these 2 weights will be an anti-clockwise moment. So the clockwise moments is the distance from the pivot, 1 unit, times the weights of the dynamite and the cat, so 1 times C plus D. The anti-clockwise moments, well, it's 1 unit times the weight of the bucket, so 1B, but it's 2 units times the weight of the cat, which is 2C. And we multiply that out. C plus D is B plus 2C, and we make the dynamite the subject of the equation. We get B plus C. But we already know that the weight of the cat is the same as 2 buckets. So D is equal to 3 buckets. So we get the same result as we saw in the other part of the diagram. So now that we have a link between the weight of the cats and the buckets of chickens and the dynamites and the buckets of chickens, we're ready now to use the principle of moments to balance the clockwise moments on the right here with the anti-clockwise moments on the left. And all these weights, all these masses on the right hand side will have a weight acting downwards. And so all of them will have a clockwise moment, whereas all the weights on the left hand side will have an anti-clockwise turning effect, an anti-clockwise moment. So if we look, there are three main sections on the right here. We have at the very end this section here comprising of two buckets and a cat tied on to the very end of the pole or whatever it is that's holding them up. We have a bucket of chicken and a cat which is on this pivot here, and so their weights will actually act through that point. And at this point we have a bucket chicken sitting there, and also we have these two dynamites that are acting through this point. They're held on by a string there, and so it's as if their weight is just hanging from that point. And so we can now do the clockwise moments of all the forces in the right hand side. And the first clockwise moment is this one here. It's 7 units across, and the weight going down is of a cat and two buckets. So I'm first of all going to say that's 7 upon a cat and two buckets. But we also have the moments due to this force here, and that is 5 units across, and it's the weight of a cat and a bucket. So when we write that in, we also have, so I'm adding it on here, distance of 5 times the weight, a cat and a bucket. And finally, we have 3 units across and the weight of a bucket and two dynamites. So the distance is 3, we have a bucket and two dynamites. And that's the clockwise moments. Now for the anti-clockwise moments, all of the forces are acting 2 units away, because this string holds the two cats, the bucket of chicken and the dynamite, and they're all hanging by that one string, and it is attached 2 units away from the pivot. But also the white box and 2 more dynamites are also situated 2 units from the pivot. And so everything is 2 units from the pivot. We can write that the anti-clockwise moments are the distance 2 times, well, I've got the white box, I'll call it W, plus the 2 dynamites on top of it, and the 2 cats, and the bucket of chicken, and the other dynamite below. So the anti-clockwise moments is 2 upon W plus 2D plus 2C plus B plus D. So the principle of moments tells us the anti-clockwise moments are equal to the clockwise moments about the same point. And so these are what we got for the moments, the anti-clockwise moments and the clockwise moments. And we just equate them, we put them equal. Multiplying out the bracket gives us these next couple of lines, and then we want to find what's in the white box, what W is. So 2W is equal to 60 take away 60. They cancel on both sides. I need to move this 4C across, and it becomes 8C, because 12C minus 4C is 8C, and 22B minus 2B is 20B. So the white box holds the weight of 4 cats and 10 buckets of chicken. But we're asked to say how many cats does it hold. We know already that a cat is equivalent to 2 buckets of chicken. So that's the same as 4 cats plus another 5 cats. And so the white box holds 9 cats in it.